3 reflections, part 1. It is pretty thorough, but it's a lot of graphs, so it is a lot of pages if you see in your notes, but it's not a lot of work. Okay, so just bear with me. We're going to go through 3 types of reflections. We're going to reflect over the y-axis, the x-axis, and y equals x. Okay, there's 3 types of reflections we're going to talk about. So the first one we're going to talk about is when you take the function. Oh, sorry, I do want to point this out. What's an invariant point? This came 20. Invariant point is a point that does not change when you do a transformation. So they're points that are shared. So if I move my graph or just it's the point that doesn't change. That's not right. Doesn't change. Right, you'll see. It's going to be a point that's on your reflection line. So if I reflect something on a reflection line, that point doesn't go anywhere, right? So like if I, for example, let's just take a picture. Let's say I'm reflecting over the y-axis, and I have a parabola. When I flip, this point is going to stay there. Like that's going to flip over here, this is going to flip over here, so it's going to look like this.
Oh, it's whatever stage of the reflection line?
Yeah, exactly. Because, come on. All right, go yellow. It's going to look like that now when it reflects. Here to here, here to here. But that point stays the same. That's the invariant point. It's going to tell us that in the notes, but now you know. Okay. All right. Let's look at the first one here. So first one is, we're looking at f of x. So there's the function flipped. So that's your classic parabola in the front with a negative, where your parabola flips up and down, right? So just in general, when your parabolas flip up and down, what are they flipping over? The x-axis, right? And so that's what we have to think about in terms of how they're flipping. So the graph, here, let me get, we're just going to do part 1 first. Okay, write the equation if you flip it. So if you flip it, it's going to be negative x squared plus 10x minus 25. Okay, and then that graph looks like this. Okay, obviously mine's not to scale as theirs, but you can see it. You can use a graphing calculator sketch if you want. I just kind of roughly sketch it. We know it flips over the x-axis, as we just talked about. State the coordinates invariant point. Invariant point right there that they flipped over. That point would be 5, 0. 5, 0 is the invariant point for that parabola. Okay? If you're not sure what I'm saying, it's this point here because this point didn't change. My parabola's going up. I flipped it. That point is still part of the graph. It didn't move. Because the reason it moved because it's on the reflection line. Okay, questions on that? Another way you could check your points is you could plug the 5 into the original, plug the 5 into the changed. They should both get 0. Okay. All right. Cool. All right. Part 2. Now we're looking at a cubic one. So the graph of f of x cubed minus 8 shown. Write the equation. So if I do negative f of x, we just flip the signs. That's a negative f of x1. So that means we're going to be up here at plus 8. Okay, and it's going to go like that. And it's going to go like that. So it looks like that roughly. Okay. Again, just kind of, if you can visually see it, just look, it's reflecting over this line. So see this dot? Reflection. See this curve here? Reflection. See this going straight up and down? Reflection. It's reflecting over the x-axis all the way, with your invariant point being right here again, right? On the spot that is the reflection line. In this case, 2. 2, 0 is your invariant point. As we've already been saying, how do the graphs compare? They compare because they are reflecting over the x-axis. Okay, and then we're going to look at the v here. Okay, look at the absolute values. So this one, they're not giving you the function, even we know it's an absolute value because it's a v. They want us to flip it again. So if we do that, we know that we're flipping. So this would be 2 up, it's going to be 2 down. And that's going to stay. That's going to stay because they're on the reflection line. This would be up 1. This would be up 1. That's how it would reflect. With the invariant points being 3, 0. It doesn't ask for that. We're just doing it. Invariant. And 1, 0. That's your reflection of the absolute value. Okay. So all in all, it's flipping the y. So it's making your y from positive to negative when you do that. Okay. And that's what this is telling you here. Okay. Second piece. Instead of the function being negative, we're going to plug in a negative x. When I think about that, so we're plugging, instead of a positive x, we're plugging in a negative x. So that's going to positive x to negative x, right? So it's going to reflect over the y-axis now. That's what we kind of can make a conjecture on. All right, so we'll go and do that, though. So write the equation. The important thing to understand is that you do this, when I square a negative, it's still positive. So when I rewrite this equation, put a negative x in here, negative x squared is still x squared. A negative 10 times a negative x is a positive 10x. And the 25 says 25. So that's our new one. This does factor. X plus 5 squared, which is a movement of a parabola, left 5. So it's right here. You can see there are effective. Mine's a little wider, but they will be the same. What is the coordinates of invariant points? It is not in the picture. What's the coordinate of the invariant points for these graphs? Good. 0, 25. Why? Right, because they both have a y-intercept of 25, and that's on right? If you're reflecting over the y, that's the invariant point that's not going to change. Okay, good. Any questions on this before we keep going and flipping on the y? Good? Okay. All right, so let's go the cubic one now. So if we do the cubic one, we're going to change. We're going to put negative x in. Now, if we put negative x into a cubic, what happens? It's negative now. And so you're staying here. So now it looks a little bit more like that, as it's reflecting over the y-axis still. The coordinate invariant point is 0, negative 8. Good. And how do they compare? We're kind of getting the idea. They reflect over the y-axis. Very nice, very nice. Again, they're being redundant, so you have a tendency to get bored right now. I really try to encourage you to stay awake and get this stuff down, because this stuff is supposed to be easy. I don't want you to make it harder just because you tune out a little bit. Try to stay on board. Now look at the V. We have one more section before we actually take some examples. So we're going to do the y over x line. Those x lines, sorry. So this one, so the idea, so it's flipping over here, so it's here. That point's the same. Here. There it is. So my invariant for this one is 0, 1. If you just want to write that down for practice. Okay. Good. All right, so the third and final type of reflection, the inverse, which we did this already. So that's the good news. We did inverse relations for Unit 1. So we already know this, but inverses reflect over the y equals x line. Okay, So the y equals x line is what we're looking for here in terms of the parabola. It's the one that weirdly turns the parabola sideways, and etc. So the graph y equals f of x is x minus 5 squared. It's shown in the equation x equals f of y, solve for y. So we go ahead and just do our work that we did for inverse relations. So we're going to swap them. So we're going to go x equals y minus 5 squared, and then we're going to solve. So we're going to get plus or minus square root x equals y minus 5. Add 5. Add 5. 5 plus or minus root x. So that means we're going to go up here at 5. A plus root x would be like this. A minus root x would be like this. And so it turns it. And then if you want, I can just show you that this is the y equals x line. My point over here is not very good, but the point is that it's supposed to reflect over that. Now, here's the thing the last class kind of struggled with. Although, let's see if we can mark these. We have, I know this point's off, okay, I'm sorry. I'm just going to kind of there, there, but we also have here and here. Why are these two not invariant? What's that? Okay, good. They're different chords on the reflection. That's a really good way of putting it. Anybody else? Not really because of restrictions, but you're a good idea, Jake. Right. The reason they're matched up like this, guys, is because it's a 2-4 and a 4-2. 2-4, 4-2, right? And so these coincide with each other in terms of flip, but they're not invariant because they do flip. Like this will flip to here and this will flip to there, so they kind of swap spots. These ones is like a 3-3. 3-3 is 3. 6-6 is 6-6. And so these are actual invariant points on the y equals x line. Okay, but if you go with what we've been doing today, all invariant points are on the what? The reflection line, right? So that makes sense that these two don't work. Anything else there? Does that make sense at all, or is that confusing? Okay. All right, so that's what C is here. You can put that in your own words however you want. What they have in here is very complicated, but I would just simply say that if you want to label these, like we call these C and D. C and D are flips of each other, but not invariant. A and B are invariant because they are the same flipped. Okay. Cool. All right. Let's try 2 here. So now we're doing the inverse of the cubic. So we're going to write the equation for that. So we're going to do our swap here. So we're going to go x equals y cubed minus 8. So then we have x plus 8 equals y cubed. And y equals, don't put plus or minus because it's cubic. So that's what we have. Y equals cube root of x plus 8. And that's going to go right about something like this. Okay. That's the y equals x line just for reference, so you can kind of see that reflection there. Okay. And then the invariant point's this guy right here. It's not a whole number, so they don't have you label it in this one, but there's a point there which they cross in that line. Okay. You can always try points here. If you're saying how are you getting those graphs so fast, I'm just kind of skipping the point of trying points or putting in my calculator. So if you're like, how are you getting the graph so fast? Well, I have the picture, 1, and then 2, I'm just speeding it up a little bit in terms of putting your calculator or plotting points. You can always plot points. You guys can always make graphs, right? Like, for example, if I put 0 in, 0 here, cube root of 0 is 2. So 0, 2. That's why that was right there, 2. So we marked it. How does the graph compare? You get the idea. It's reflecting over, not of, over. Y equals x line. Okay. And we'll do the V, which is a little confusing, but okay. All right, so let's try the V here. So as the graph of f of x is shown, sketch the inverse of it. Remember, you can here, you could draw the y equals x line and try to swap the points. That can get a little bit confusing. Or you can just find some points and flip them, right? So if I come over here, like this point here is negative 1, 2, right? So 2, negative 1's a point on the new one. So I go here to 2, 1. All right, you can do that as well. Do however you want. I'm going to go ahead and just kind of reflect it just by the picture. So I'm going to go up here. I'm going to draw y equals x. Okay. All right, so now things that I noticed is like this line here is going to mirror over here. See that? It's going to flip like that. So for example, you can get a point if you want. This is negative 5, 2, or negative 2. So it's going to be negative 2, negative 5. Okay, and then let's do this one. Negative 4, negative 1. So negative 1, negative 4. Wait, what did I do that? Oh, I'm on the wrong side. I'm positive. Negative 1, negative 4. Negative 2, negative 5. That's better. So it's going to go like this. Like that. And then see this here. This line's kind of the weird one where they're mirroring each other, but they're already there. So it looks kind of weird. But see how this one goes infinite this way? So that means this is going to keep going. So that flip, that's going to make this keep going. So that's what it looks like. These are still part of it, but you see what I'm saying? Like this line, it's already here. So when you flip those, that line's already there, so it looks a little bit weird. But that's the absolute value flipped over y equals x. All right, summary of those three things we just did. All right, so let's fill these in. We'll do some examples and call it a day. All right, if the graph of y equals f of x is reflected in the x-axis, then if the graph of it is the negative f of x. So if you flip over the x-axis, you're flipping the negative f of x. If the graph of y equals f of x is reflected on the y-axis, you're plugging in a negative x. Okay, I'll wait for you. Okay, part 3. Okay, it's reflected on the line y equals x. That means it's graph of, what's the result says? Yeah, x equals f of y, and then or f inverse of x. Okay, those are your two options for that. Okay. All right. All right, a couple examples here. All right, so the graph of f of x is shown. Sketch negative f of x. So negative f of x, you know it's going to reflect over what? The x-axis, right? So if I know that's going to happen, that means that these are invariant points because they're on the x-axis, and everything else is going to flip. So that's at 6, it's now going to be a negative 6. That's at 6, it's now going to be a negative 6. That's at 4, it's going to be a negative 4. This is at negative 3, it's going to be a positive 3. And then we can slowly draw that now. And so there's the reflect. Okay. This graph, which is the same graph, is also now reflected over the y-axis. Now we're flipping our x's. So negative 5 is going to be positive 5. Negative 4 is going to be positive 4. Negative 2 is going to be positive 2. That's invariant. That spot's going to stay the same. 7 is going to be negative 7. And I can use this one too. 9 is going to be negative 9. Okay, so it should be like that. And we have the inverse one now. So if we, okay, besides being tired. All right, let's try the inverse. All right, so the inverse one, I know these dotted lines make it harder mine, so hopefully it's easier for you to see on yours. So we're doing y over like y equals x. So for these ones, without drawing the line, let's not draw the line this time. Let's just flip the points. So negative 5, 0, 0, negative 5, right? Negative 4, 6 should be negative 4. Negative 2, 6 should be 6, negative 2. 1, 2, 3, 4, 5. Oops, that's 5. Not labeled very good. So it should be there. And 6, negative 2. There's that. Okay, so I've done these 3 points so far. 0, 4 will be 4, 0. 9, 0 would be 0, 9. Let's see what else we want to do. 7, negative 3, negative 3, 7. Right there. Okay. All right, so then if we use this for a guide now, you can kind of see the reflections taking place. So it's going to kind of go like this. It kind of stays on this line. And then goes like that. Why does it stay on this line? Because this line right here is reflecting directly on top of itself. So it looks kind of weird. But like this section here, from here to like right about here, is just reflecting on top of itself. So it looks like one continuous reflection. That's what's happening there. Okay. All right. You guys doing good? All right. So let's go ahead and do the graph drawn. The thick line is the reflection of the graph drawn on the thin line. So write the equation of the graph drawn on the thick line. So we're just doing it just in terms of f of x. So what is this one doing? How's it being reflected? Is it inverse? Is it y-axis? Or is it x-axis? Inverse. So this one was just simply, whoops, this one's y equals f negative 1 of x. Oh, negative 1. Not doing derivatives yet. Not f prime. Okay. How about b? Right, so over the y-axis. You can tell by where it's intersecting, right? So it's intersecting right here, so that means it's reflecting over this, which makes it that, right? And then where's the third one intersecting? Right, on the x-axis, which makes this one that one. Okay. All right, so let's go ahead and just, we'll stop there today. I wanted to finish, but we'll do combining reflections on a second video. So that's good.